Hello class, this is chapter 10, comparing two populations or groups. So we are going to learn or review how to look at a two-sample distribution for populations, proportions and population means. And this is David Chen. My group is Tai Chen, Gabby, and Aaron. All right, so first we're going to look at z-tests and z-intervals. Our conditions are, the first one is that it has to be random. The data must come from a random sample. The second one is 10%. We all know that one. The large counts, remember, you have to do p hat times n1, and then n1 times 1 minus p hat. The equations are here, so just make sure you remember how to do large counts, and all of these must be at least 10. All right, so these equations. If you want, you can pause the video and look at these equations and memorize them. They're very useful. And z, when it says z here, z star is the standard critical value, so basically how many standard deviations it is, and you find it with the equation 1 minus c over 2, and then finding that value in the chart, and then you have to look to the corresponding z value. All right. And then for z-test, that was for intervals, and for a test, you calculate it using the z equation from that my mouse is hovering over. All right, next. The confidence intervals for mean and the t-tests. So there are the same conditions except for the normal and large sample. And this one says that each of the two populations must come from an approximately normal distribution. It's the same concept, but the way you do it is different. So instead of having, n times p be and n times 1 minus p have to be greater than or equal to 10, you have to make sure that n1 and n2 are both at least 30. So the groups have to be big enough. All right, next, the equations. So for a two-sample confidence interval, your equation will be pretty intuitive. And the t star is the critical value, and you use the chart in a similar way, except you have to do the degrees of freedom, which is just n minus 1, and then you find your t value. And the same goes for the, or actually, for means, for the t-test. You can do degrees of freedom in two ways. You can use technology. You can do it from a calculator, and then you can do a conservative method. So df equals n1 minus 1 and n2 minus 2. You have to choose the one that's less and then go with that one. All right. And finally, reminders, or not finally, this is just reminders. A pool population, remember those? Those are going to be number of successes over the number of, the sum of the number of successes over the sum of the total number of individuals. And you can only use that when p hat sub 1 equals p hat sub 2. Which means that the population proportions have to be the same, or the predicted ones, pardon me, or yes, when the null hypothesis of that is true. All right, and the pooled z-test for a difference between these two pooled proportions is as follows with that equation. And calculator work. This should be pretty easy. As always, stat tests will bring you to the tests page, where you can choose two proportion z-test for exactly that. And you have to make sure that you're not choosing t-test or t-interval when you're actually trying to do z-tests. Okay. And these exam tips at the bottom are just saying that you should not necessarily use the formula. You should always try to do technology because that's going to be more accurate. You just have to make sure that you name the procedure you're using and you report these statistics z and the p-value as part of the do step. All right, so for the z interval, it's almost exactly the same. Same for the t-test t-intervals. These are just excerpts from the book. You can pause the video if these are useful to you. And these are some helpful practice problems to look at. Highly recommend looking over them. Yes, very relevant, and that's all. I hope you are thoroughly prompted. Your memory is back to how it was when we first learned the unit.